Okay, so the suggestions I got from the class, good suggestions. And subtract 1 from both sides, that's pretty useful maybe. Okay? Multiply both sides by 2, because of course, anytime you've got a denominator in an equation or denominators, you find a common denominator and multiply through the equation by that common denominator, so you don't have to deal with denominators. Okay? So we do that. So here we have this, right? And what do we do now? Well, we're going to expand that x minus 3 squared. So now we're going to do this using the distributive law because people never remember magic. But that's all anybody ever gets taught is magic and superstition. Okay? So I'm not going to use magic and superstition. I'm going to do this in a secure manner. Okay, well, what's x minus 3 times x minus 3? No magic, no superstition. You use the distributive law. Okay, so first of all, this is 2, and I'm going to use a bracket here to isolate the x minus 3 times x minus 3 so we see what it is. X minus 3 times x minus 3 is x times x minus 3 minus 3 times x minus 3. Distributive law. Comfortable with that? I think so, because as I say, your algebra is pretty good. So we have x times x minus 3 minus 3 times x minus 3. And now x equals 2 times what? Well, what's x times x minus 3?
X squared.
X squared? Anything else?
Oh, minus 3x.
Yeah. Now we're going to use the distributive law. I mean, you just did, but don't know if you did that by superstition or by thinking that you were using the distributive law. Okay? And we want to stamp out superstition because it gets in the way when you're trying to do the mathematics. It's okay to have a superstitious idea of what this is going to look like, but then make sure we know what the rules are. And when I say superstitious, I mean just by habit, by what it looks like, okay? You often misled. And, you know, there's an epidemic of that. Probably always has been, so it might not be new. Anyhow, x times x minus 3 is x times x minus 3 times x. Just using the distributive law, right? And then 3 times x minus 3 is 3 times x minus 3 times 3. Okay, now I don't need the big brackets anymore. X times x is x squared. Going to have minus 3x here. We're going to get a minus 3x here. And we're going to get a plus 9 here. Okay? Incidentally, there's an F word people use with this. You know, F-O-I. I can't finish it because it's obscene. But I still don't comprehend how mathematics instructors use that. Okay? Actually, I kind of do because when you're teaching factoring, it can be pretty handy. But other than that, for multiplying these things out, it's awful. Just absolutely awful because it distracts from the distributive law. And it doesn't apply if you had, let's say, 2 trinomials or even a binomial and a trinomial. It only applies to binomials. It doesn't apply in general, but the distributive law applies to anything. Okay, so people get hung up on that F word thing and never learn the distributive law, never think of it when they need it. So something's wrong, but I'm not going to take the responsibility to fix it. Okay, so anyhow, here we have it, right? So now we can distribute, well, let's see, so x is 2 times x squared minus 6x plus 9. There's also a formula for the square of a binomial, and it's okay to know that, as long as you know where it comes from the distributive law. A plus b, quantity squared, is a squared plus 2ab plus b squared. Okay? And that's easy to figure out from the distributive law. Anyhow, okay, so we've expanded this, and now we have this, right? Well, we still got a ways to go, so let's try to get it done over here. We got then x equals, now I can distribute multiplication by 2 here, right? 2x squared minus 12x plus 18. Okay? Now, do you see what kind of an equation that is and how to solve it?